So this is problem number 2 from year 2016, and I'm not going to do this problem, but I am going to step you through it, and hopefully you'll be able to finish the problems and get them all right. So like I said, it's a particle problem from 2016, and it's problem number 2. Okay. So it starts with, for t is greater than 0, so we don't have to worry about negative numbers, or equal to, a particle moves along the x-axis. The velocity of the particle at time t is given by, so they give us the velocity, and they're most likely going to ask us with a calculator to integrate or take derivatives, probably both, right? The particle is at position x equals 2, so it's moving on an x-axis, which is how it normally moves to keep it simple, on an x-axis, and it's at time 4, it's at 2, which it would have been nicer if it was time 0, it was at 2. So it's saying at 4 seconds, or 4 minutes, or 4 hours, it's at position 2. Okay? So at time equals 4, is the particle speeding up or slowing down? Okay? So what you're going to need to do is you're going to need to plug in 4 with a calculator, plug in t equals 4 to the velocity, right? And you're also going to have to plug it into the acceleration. And like I said, you should be using a calculator for that, so it should be pretty easy under second calc on a TI-84, second calc. Anytime it's asking about speeding up or slowing down, you need to figure out if they agree. If it's positive and positive, then it's increasing in speed. If it's negative and negative, then it's increasing in speed, just in the negative direction. And if they disagree one of each, then it is going to be it's going to be slowing down. All right? So go ahead and plug in on a calculator. You don't want to do this by hand, right? You want to use a calculator because you have to be quick. All right, next question. Find all times t in the interval from 0 to 3. So we're not talking about that time anymore. Find all times on the interval from 0 to 3 when the particle changes direction. So basically what we want to do is we want to get a graph from 0 to 3. So 0, 1, 2, 3. And we want to figure out when it's going either from positive to negative, because this is the velocity, right? We're graphing the derivative. So when is it going from positive to negative or from negative to positive? That means it would have stopped and then turned around, right? Going in the negative direction, stopping, and then going in the positive direction. Okay? If you have to actually find that time, to do that you're going to push second calc and then find a 0. You're finding that 0 or this 0, wherever that graph is. Make sure you're only looking at from 0 to 3. All right, next part. Find the position of the particle at time equals 0. So we need to find the position at time equals 0. We want to end up at 0, so we want to integrate, because we're trying to figure out our position, we want to integrate the velocity, right, dt. But the question is, if I want to end up at 0, where do I want to start from? And if I'm trying to figure out where to start from, I think the answer is I need the initial condition. I need to know where we're starting from, where our initial position is. And if nothing's ever said, then we just assume we're starting from 0. But they told us that at time 4, at time equals 4, all the way to time equals 0, right? At time equals 4, we were already at 2. So we were at 2, and this is kind of goofy right here. This is actually going to be worth points. You have to set this up. This is going backwards. Normally we have the lower number here and the bigger number there. So this is like if you were watching a movie, but it was going in rewind, right? Going backwards in time. So this is a position, and this is also a position now. Since we're integrating velocity, it goes up to position. This is basically like our plus c, right? When we integrate without the values there, the t values there. Okay, so you have to actually integrate that with a calculator now. And last one, find the total distance of the particle that the particle travels from 0 to 3. So this one's going to be pretty easy, but a little bit annoying. Once again, we're asked for distance or position, right? We're going to go ahead and integrate from 0 to 3, and I'm going to throw an absolute value around the velocity. Absolute value is going to make any time. So basically, if we had a hypothetical graph, if the graph was gonna go down like that, you can integrate and find this part and that part, right? But this is gonna make it so it bounces back up above. that negative part is now going to bounce up above. So we have all distance. And I'm going to in absolute value of v of t dt. And make sure you're writing these down, or even you could put the function in there if you wanted, because it's going to be worth points, and the answer to 3 decimal places is going to be worth points as well, along with any sort of justification that you need. Okay? So I'm hoping this helps out. I'm hoping you also are having a little bit of fun with the difficulty level of these problems. A lot of times in math, you're given problems, but they're not real problems. They're just something to do. And these actually are kind of difficult, and they require some practice. So good luck and stay strong.